Are you usually afraid of deploying to production? Or do you just hate hitting the scary button that says deploy to prod? Maybe you are not using feature flags, or maybe you are missing some key functionalities from feature flags. But wait a moment, feature flags are complex in fact. They are not just a simple solution. Usually, it's a huge bottleneck. So today I want to dive deep into feature flags. Okay, so a normal deployment to production situation without feature flags will be something like this. You have your code already merged on the code base, you directly deploy to production, and once you deploy to production, all the users are able to go through the new changes in the user experience. This is what usually is called a big bang deployment. But the other option is that you use feature flags in a way that you are decoupling the deployment to the release. This is so that you deploy to production, but through what we say here, the dark stage. So the new experience is not being used by the users. You hide through the feature flag the new changes, and you just keep the legacy code path functioning as it was before. You at the beginning set the feature flag as false. It means that users are still going through the normal path, the legacy path. So you deploy to production, the software got to production, but you decouple it from releasing because users didn't see the release new software. So how can we solve this? The first version will be something very primitive. Let's say that we just want to have something that we will be calling a data store in which we track all the status of all the feature flags that we got. So for example, here we're saying that we are tracking the progress on releasing a new feature that's called new pricing engine. And for this one, we want to separate between the users that got the new treatment, so the software that we are trying to release, or the legacy code path, so their normal production experience. This is something that obviously is not going to scale. You need your service to constantly be hitting the database. Here I'm talking about a database just as an example of a very primitive data store. It could be anything else, but the point is that you will need to go through the system in which the changes of the feature flags are being persisted. It means that when someone flips the feature flag, this change needs to be persisted, and the services that are going to be serving the user experience that you are going to be releasing needs to consume the data from this database. This is why we are using this as an example as the simplest case in which you somehow are storing the feature flag statuses in a database. What can we do to scale this? So the first thing that we can do is to scale through a cache. So if we want to scale the reads, we can keep going through the database. If we are constantly going through the database, we are going to be hitting a bottleneck on the database, and we are going to be exploding the database. We can just use a cache. For this case, in this version, let's say that this cache is going to be a hash map in the code. This is going to be living through the state of the service, and this is just going to be used for the lookups of the feature flags. It means that when there is a new request and we want to see what is the treatment that we are going to be assigning for this request, then we check on the hash map. So then we say for this feature flag, what is the treatment that we want to assign to this request? We will go through the context and how we assign treatments much deeply later. Okay, then this could be much better on reads, but then we are still in trouble with the writes. Why is that? When the operator flips the feature flag and changes the percentage of the users that go from one path to the other, we are going to be seeing that this is going to hit the exact same database that we were talking before. And then we could set a time to live on the cache of, for example, 60 seconds. So we update the cache either way every 60 seconds. This is not going to scale for two reasons. First, it might be that we are updating some servers that don't need to be updated. So if we are scaling this on multiple servers, some servers are going to get requests asking about certain feature flags, but some others maybe not. So we could be updating all the servers, which is going to be very heavy. If we do this every minute, then we are going to be overloading the servers. On the other side, it might be that those servers that actually want to answer very precisely the question of what is the treatment that we allocate for this feature flag might not be updated because this TTL might be too much, but we cannot reduce the time of the TTL without overloading much more the servers that we don't want to update. So this is definitely not going to scale. Then this will be the next version. For the next version, we're still using the same components. So still, there is a data store in which we are updating the values of the feature flags. But how these values are being propagated to the servers is a different story. This is how we get to actually scale. We keep the same server cache in a way that servers are still performing a lookup for new requests, so they are still very fast on reads, and they are updated through a new component. This new component is going to be supporting the write operation. So it means that whenever there is a change in a feature flag configuration, we are going to be performing an invalidation of the cache proactively. It means that we are going to propagate the change to the servers that are actually interested. How is that? We put this in a pub shop. And by doing this, we can notify servers in multiple different ways asynchronously without overloading them. So here then we are decoupling the operations on the flag service. Everything is associated to feature flags to the actual servers. So servers become pure consumers. We can still hold the TTL policy. Servers can still invalidate their own results and ask for new values. And these new values come from the main data store. That is actually persistent data as the source of truth. So, what's on the other side? We are still having the same path as we had before. This is still the same on all the cases, such way that we get a request, we evaluate these feature flags by calling the corresponding servers without having to worry what's the actual server that is going to take this request. The business logic that the feature flag is wrapping is still the same. Nothing changes on this side. We are just scaling everything that is happening on the feature flag service. Then we got a bit of depth before about context. So we need to talk about how we are actually evaluating these feature flags. There are multiple ways of evaluating the feature flags, but the most important way is that we want to know from the request that we are getting, how can we be deterministic on the allocation that we perform from request. It means that for the same user, we usually want to show the same experience, but there are multiple ways to parameterize this. For example, we can also take into account the country. We might run a feature flag for all the users on a specific country. So basically, we need to decide what are the parameters that we will be using to allocate the request. We need to find a way to get them all through multiple rules, if they are needed, to actually be deterministic on the request that we categorize on the same way. So for example, me as the user of a website, if I log in now and I log in 4 hours later and the experiment is still running through feature flags, usually it will be preferred for me to see the exact same experience. So consider that feature flags are really important for releasing software, but we can also use all these parameters that we've been talking about for performing data analysis. For this to be successful, it's important that there is certain mapping that it's deterministic between what the user has in terms of conditions and then what experience we are giving to the user. Otherwise, there wouldn't be a way to find a pattern from the results that we got. So, from the releasing perspective, we usually want to do something like this. This is the pattern that I've seen the most. It is based on having just a little bit of traffic at the beginning through the feature flag to see if anything is exploding, and if nothing is like that, so we gradually go from not going through the new treatment at all and getting to the full release. Everything is going through the new software. There are some things that we need to take into account when we are doing a gradual rollout, as the one that we were just seeing. The most important one is, how do we solve state, given that there are two paths that might be doing more or less the same and probably writing to the same DB, to the same data store. We need to decide which one is going to be writing to the database. This is something for which we want to build trust. The purpose of this, on very simple terms, is to get requests flowing through both paths and see that for the new path, are we finding any mismatches between what we wanted to show, so basically what's going on in production, which is what we say that's the safe, reliable path, to what we are showing now. And if there are any mismatches, we are going to be counting them and logging them in a way that we can analyze them and keep iterating on this experience until we don't have any mismatches at all. We are only going to be performing the gradual rollout when there are no mismatches. So if we do something like this, we are not going to be executing anything really on production on the new path. Great, so we were talking about an architecture that is designed to scale both on writes and reads, but definitely it's going to have its ceiling. And how do we solve this? Here I've been giving some examples of how we could scale the same architecture. We will still be having the same asynchronous communication between components through a message broker, for example, Kafka, and then we could be scaling the database through multiple mechanisms. Then the complexity of this could still scale. By getting into distributed systems like this, we might get into other types of trouble. As for example, how do we solve the consistency on each of these data layers? Today we've talked about how to introduce feature flags without making it be the bottleneck of your architecture. We've also talked about how to use feature flags to perform analysis as part of the experiments that you perform in your product releases. So to summarize, feature flags are another living component in your system. You need to take care of the whole life cycle. You need to build a really good architecture for it, and you need to take care of maintaining them. If there is any interesting experience that you went through using feature flags, any scalability issue, any complex project in which you integrate in them, hit me up. I'll be really happy to be talking about them.